These series of videos are demonstrating how to automate economic policy through code. A link to the GitHub repository is included in the video description. In the previous video, we built a database, showed how to add changes to it, and toured the schema. In this one, we're invoking each of the backend services to reproduce the request and approval flow of a transaction. Alright, open the inventory file stored in Project Root. Though this file is created from a make command, we're marking it up temporarily to learn which services are used to create a transaction request and add an approval. All requests sent to the app are first received by the GraphQL service, which routes requests to the other backend services. GraphQL also structures requests and responses and gives users a convenient way to learn which services are available and how they behave. And that's all you need to know about GraphQL. This GraphQL service does not query a database directly, but if you want to test routing, first deploy your lambdas and database as demonstrated in video 7, then cd into the service's GraphQL directory. Make get secrets with an environment assignment of dev. You'll notice the .env file appear in your GraphQL directory. That .env file stores the resource names for the other lambdas. Make run in the current shell. Now the GraphQL server is running locally with the variable assignment stored in the .env file. To send it requests, open the endpoint tool and import the GraphQL collection under the services GraphQL Postman directory. This collection requires setting a GraphQL URI variable. Copy the variable name, select environments on the left side, select the plus button to create an environment, name the environment if you want, paste the environment variable name in your new environment, and assign it the address your local GraphQL server gave you, but without the trailing /. Paste the server address as your variable assignment, save the environment, set your new environment as the current environment. Now switch back to the Balance Request tab. Okay, John Smith, you want to know your account balance? Send the request. The John Smith balance request is received by your local GraphQL server. GraphQL routes the request to the balance service in Lambda. The balance service queries RDS, and it should be fetching it from a key value store, but we're keeping architecture simple right now. The balance Lambda responds, and your local GraphQL passes the response back to you. So GraphQL is step 1, since it routes requests to the other backend services. If you're wondering about authentication, it's handled right before GraphQL in an API Gateway v2 authorizer that expects a JSON Web Token. You'll find that config under Infrastructure, Terraform AWS, Modules, API Gateway v2 Lambda. Open the v1 folder and API Gateway v2. Now scroll down to the authorizer resource. You'll find Cognito configured as the identity provider. Also, you can disable authentication in Terraform for expedient development. So when requests are sent to GraphQL, tokens are first tested by API Gateway v2, and they're created when you sign up or sign in on the web client. You can see that under the client directory. Open client from Project Root, Source, Auth, and Cognito. There's sign up near the bottom, and sign in towards the top. The Cognito web browser package will stick your token in the local storage of the browser for you. From there, you just pass the token in an authorization header whenever you're talking to GraphQL. Finally, going back to GraphQL, open the auth package. When authentication is enabled, GraphQL will parse the account name from the JSON Web Token tested by API Gateway v2 and pass it on to the GraphQL resolvers as the auth account. That's why you find an account repeated in a GraphQL request. Only authenticated John Smith should know the John Smith balance. But John Smith is also welcome to know the balance of the city of Los Angeles. Okay, authentication received a brief code review. We're not demoing any of that here. Authentication standards are well defined. Transaction accounting standards are not. So let's pick up where we left off. A cashier is ringing up items at the register, or whatever client application they're using. The transaction items are sent to the rule service via GraphQL to test if any rules such as taxes apply. If a rule is matched, at least one additional transaction item is returned. You send rules a single item of bottled water with a price of 1. You get back 2 items. 1 is the bottled water you priced at 1, plus a new item, a 9-cent sales tax. Let's test it locally. By itself, no Lambda, no GraphQL. Just Control-C out of this one. We'll continue invoking the services directly. First, we need a local database with schema. You've seen this before. CD double up and back down into migrations. Make run to start Postgres and Docker. Wait for Postgres to accept connections. Now we'll load schema. Open another shell and CD back into migrations. Make up Docker with a DB assignment to test. This command only up migrates Postgres and Docker with all the migrations. Now your database is up with schema, and you're ready to test rules locally. CD up, then down into services rules. Make install to install dependencies. Now make run. You are invoking the rules service locally with a bottled water transaction item. The make run command in the rules directory currently references an invoke module under the source directory. Nothing fancy. The module just hardcodes a path to a bottled water JSON file located in services, go package, test data, bottled water JSON. Bottled water is the item, and the price is 1. Okay. Back to the rule shell, which printed the response from rules. You sent your local rule service a single entry transaction item list pricing bottled water for $1. The rule service found a 9% sales tax creditor transaction rule, applied it, and gave you back 2 items totaling $1.09. Here's the 9-cent sales tax that was returned with your bottled water item. Now scrolling down to this approvals list for a moment. Again, in addition to automating taxes, dividends, debt service, and wage payments, transaction rules also enable people to automate their transaction approvals. Not indiscriminately on the debitor side. For example, the debitor here doesn't have a rule appending an approval timestamp to every request they receive, because that's the same as handing money over to everyone who asks for it. These creditor approvals do have rule-edit timestamps. You can see the IDs for the rule-edit approvals. Now these approvals don't look like they have timestamps yet because their approval time property is assigned to a Postgres function that will turn into a timestamp when it hits the database. Visually, these occurrences of the Postgres function are helpful, but they'll get switched to a Boolean or a binary later so the timestamps are set by the service. That way they don't vary on insert. Anyway, some folks don't mind accepting any offer of money, but a free market can't assume that. Automating an approval once given, that we can do, by adding an approval rule for the account owner. Now, if you're paying close enough attention, you may have noticed the list of creditor approvers for the state of California account. Remember, long lists don't cause as much trouble as they used to. Those who are upset with the performance of their current government may wish to swing to the extreme and set fiscal policy through direct democracy. Wiring up voting machines to the System Accounting Rules Service isn't a problem. But since being born isn't the only requirement for managing a financial account, and that's why the most successful businesses in the world aren't the ones managed by everyone. System accounting solves the problem more elegantly by revealing why some financial account managers, proven through data, are preferred to those who promote themselves through television. Increasing accountability through data eliminates a big cost imposed on the public by the absence of evidence. More important than a constitution is the knowledge of how to fund its enforcement. 2.5 centuries ago, a constitution was written by people demanding no taxation without representation. Well, now it's their turn to receive a demand. No representation without accountability. Okay, that's rules, which is step 2 in the transaction process. In system accounting, all transactions start out as requests. Once items are rung up at the register, the cashier sends the user and rule-added items as a request to the Request Create service. GraphQL is in between, but we covered that detail. When the Request Create service receives the transaction items, it stores the request in memory, then creates a copy of the request with only the user-added items. Now the request only has the items the shopper brought to the register. No taxes added. Next, the Request Create service sends the user-added items to the Rules service. In storybook fashion, the Request Create service is saying, "Hey, Rules service, these are the items the user sent you at the beginning. Please repeat for me all the items you told them to include, like taxes, so we can prove everyone is aware of their commitments and servicing them." Rules then responds with the user and rule-added items. The Request Create service then tests the request it received from the user for all the items repeated by the Rules service. If the original request from the cashier proves to include all the items sent again by Rules, that is, they've got their taxes and whatever else they've agreed to include, the Request Create service says, "Okay, they're transacting their immediate and expected items. We're moving forward." Account profiles are added to the requested transaction items. A transaction is then added to the database and returned. Next, transaction items are added to the database referencing the transaction ID that groups them. And approvals are added referencing the previously added transaction and transaction items. Now, if you already have your sea legs, you might refuse to hop aboard this boat with all these inserts across multiple tables not in a Postgres transaction. Yes, all these inserts belong in a Postgres transaction, and that's a to-do. Explaining the natural mechanics of a financial transaction becomes a minefield of confusion to cadets if you're switching between definitions of the word transaction and flashing them images of common table expressions. Sticking to simple dot notation with the word create is more convenient for story time. Okay, back to the story. Some of these approvals already have timestamps because they were added by a rule beforehand. For example, whoever is running the State of California account will have a rule approving their acceptance of a tax payment. They're not going to sit there all day hitting a button approving tax payments from everyone else. But the person who sent the current request, that is, the person ringing up the items at the register, is currently approving the price they're offering the buyer. "Oh, you want to buy this bottled water? Well, I approve you buying it for $1. So approval timestamps from the person at the register or the store owner are added here. Open the Approve function. Before an approval, debitor accounts are tested for sufficient funds. Naturally, and by naturally a conservation law is intended, you are not allowed to consume more than you produce in system accounting. But if there's a credit company who wishes to offer you overdraft protection, as a rule, the credit item added by that overdraft protection rule will help avoid an insufficient balance error from system accounting. System accounting enforces a conservation law through cross-account, double-entry accounting, and is not a lender. Instead, system accounting conserves default risk to those who consume it, or lenders. Okay, once debitor balances test sufficient for a debit, approval times from the requester are added. And for transaction items where all approvals are in, timestamps are copied from approvals to transaction items. Copying approval timestamps to the other records just helps avoid expensive queries. Finally, if 0 approvals are pending for all transaction items, then we have an equilibrium, which informs how to optimize production. If consumers are paying more, produce more. If they're paying less, produce less. And learn about all these changes so you can respond the day they happen. Of course, there's an optimization on the consumer side as well. No matter what this free-speaking salesperson is telling you, you don't need to pay more. Because the data says there's plenty. And if there's a business owner exercising their right to free speech by not saying a word about the freakishly large markups they're forcing on buyers, well, as a consumer of return or investor, the data also says there's plenty. So you should dive right in and rescue consumers from that greedy markup troll hiding from competition. To identify an equilibrium, we get the last timestamp from among the approvals. Set that last timestamp as the transaction equilibrium time and change account balances. The copy approval times function then exits and notifications are sent. Now let's test it locally. Got your Postgres container running? Check. Open a Postgres client since we're inserting a transaction request record, and we'll briefly tour the 4 tables involved in a transaction while we test. The transaction table is the first table to receive an insert. Select star from transaction. We'll label that number 1. Again, no mention about milk, bread, and eggs in this table. You just need an ID from here to group transaction items. There's only 2 transactions simulated by the test seed migration. The transaction item table has a lot more responsibility. Select star from transaction item. This is table number 2. Milk, bread, eggs, their taxes, and their prices are stored individually in the transaction item table. And you may reference a transaction ID to learn of all the transaction items in a transaction. Select star from transaction item where transaction ID equals 1. See how all these transaction items are grouped by a transaction ID of 1? This is a single transaction. And see how accounts vary? At least among the creditors. Some items are rule generated because they have a rule instance ID. And you can tell this is a request because approvals are pending from the debitor or customer, Jacob Webb. Then there's the approval table. Select star from approval. That's the 3rd table involved in a transaction. Humans own items. Their approval to buy and sell them is required by a free market. Here's the pending approvals from the Jacob Webb account. He's not going to approve each one manually. He'll approve once. But as his summary approval references transaction items with varying creditors, they enable changing multiple account balances in a single transaction. Everyone gets paid immediately. As the work of dividing payment up to entitled parties is automated, the opportunity to exploit middling these transactions and increasing their cost is eliminated. Finally, there's the account balance table. If you have an account balance, it's because you've earned more than you've spent. These balances only change when requests turn into transactions, or when all the approvals receive an approval timestamp. We'll label this one number 4. And now, show the transaction item table again so we can test before and after calling the request create service. There are 12 transaction items in this table, spread across 2 transactions. Open a shell, CD into services request create. Make get secrets with an environment assignment of dev, and make run. Now return to your Postgres client and run the transaction item query again so you can see the transaction request you created. There's your new transaction items. They're grouped as transaction ID number 3 with debitor approval timestamps pending. Pausing for a moment to describe a shorter alternative ending to this story, requests can become transactions immediately. That is, when they're received by the request create service. For example, as described in the previous video, the store owner can create a rule approving payment for items, and so, rather than the cashier ringing up items at the register and sending the request, the customer originates the transaction request from their mobile device, and the request create service will add their debitor approval. Since creditor approvals were already added by the rule service, there are 0 pending approvals. So balances change, and that's the shorter end with the request create service as step 3 in the transaction process. And because it asks rules if the buyer and seller got all their items, rules occurs again as step 4. Then the request create service wraps everything up as step 5 if the request it's handling proves to include the current and expected items repeated by rules. Now, going back to the old-fashioned way, if approvals are pending, meaning a transaction is still in request, approvers are notified and they send their approvals to the request approve service. That's when a request becomes a transaction. And final step. Return to your Postgres client. Observe how the request create service created a request with transaction items grouped by transaction ID number 3. So, set the test ID variable to 3 in the request approve makefile. Now open a shell. CD into the services request approve directory. Make get secrets with an environment assignment of dev. Now make run. Return to your Postgres client. Once again, see those nulls? That was before. Now repeat the transaction item query. This is after. Locate all the transaction items grouped by transaction ID number 3. Observe the values in the debitor approval time column. Nulls are replaced by timestamps. Because all approvals from debitors and creditors have timestamps. And for all accounts involved in this transaction with an equilibrium time, their balances are now changed. Balances are measured as the sum of your revenue minus the sum of your expense, or profit. Coupling this condition with a conservation law and measuring its aggregate change across all accounts eliminates the ability for a Federal Reserve to manipulate the capital market, because the risk-free rate is now the measured rate, or the empirical rate. System accounting measuring return by what happened, and not what committees think should happen, empowers the public to chase out the real occupiers in the land of return. Next time members of a Federal Reserve Committee decide to conveniently target a 0% interest rate for banks, you can say, well, Federal Reserve Committee member, the accounting data says I can expect at least 5% of my money. So, no, I won't be lending my money to any of your 0% buddies. Data before democracy and system accounting means there will be no exceptions extended to government-chartered lending companies. After spending whatever's in your vault, no matter what a democracy says you can claim is still there to your depositors or investors, if you're running a lending business in system accounting, natural physical law will dictate you tell your investors when their money was lent. And if the accounting proves you know what you're doing, then we all want to know about it, so we can lend you our money. And if the accounting proves you don't, democracy won't help you pretend like you do. Got your degree from a committee. Got your title from a committee. Got your charter from a committee. And got your rate from a committee. Now we'll see how you stack up when the only vote that counts is the one cast by the measure of your own performance. Alright, notifications aside, the request approved service is the final service in the transaction process. To summarize, in addition to structuring requests and responses, all requests are received and routed by GraphQL. Users ask the rule service for all the items they need to transact. The request create service creates transaction requests, and it'll create a transaction if 0 approvals are pending. Rules also repeats current and expected items to the request create service, so it can test if users are servicing all their commitments. And when approvals are pending, users may add their approvals through the request approved service. The remaining services here are balance by account, gets your account balance, notifications get, gets your notifications for you, notifications clear, clears your notifications, notifications send, sends your notifications. Then there's request by account, which queries for requests by account and responds with the most recent 20 requests. Request by ID queries for a request by ID and responds with it. Transactions by account and transaction by ID perform the same tasks as the request services, but with transaction records. Remember, transactions and requests are stored in the same tables. Their only difference is that requests don't have all the approval timestamps. WSS Connect creates a secure WebSocket connection for clients receiving real-time notifications. And AutoConfirm is used by Cognito to expedite development. Currently, when an account is created, Cognito triggers AutoConfirm. AutoConfirm then tells Cognito to skip confirmation so developers don't have to do that, and creates a California user in RDS Postgres in case you want to test triggering California sales tax transaction rules. The Go Migrate service standardizes database migration deployments from Lambda. Check in your change to migrations. The Lambda will deploy it for you to your dev environment. And that's exactly how it'll deploy to prod. DB Reset is another internal convenience tool that resets your RDS database upon receipt of an HTTP request. Helpful when you're not near a terminal. Finally, the client. Little old web client for demo. The public can come up with their own clients. Okay, let's tear down what we spun up. New shell and CD into migrations. Make clean to shut down Postgres and Docker and clean up the data. In the next video, we'll continue our dive into the services code with GraphQL. You may subscribe, share, and contribute from the buttons and links in the description.